Hello? Yes, all good? Yes? All right. So I'll start. Thanks a lot for having us this year again. Very excited about this first attempt at making a satellite event and yeah, streaming both ways, in both directions. And so for that, I would like to thanks a lot Amanda, who's been like instrumental in putting this together, and of course Vivian on our side, who have like done a lot of work to make this happen. So thanks a lot, guys. So switch. Okay, yeah, it works. Okay, so who I am? I'm Remy Bertot. I'm one of the co-founders of Passbolt with Cedric and Kevin, and we've been users of CakePHP since version 1. So it takes us a long back. And one of the first applications we built together was an e-learning platform called Click on French, and we've been not super active contributor of CakePHP, mostly users. We have helped a lot. Help a little bit in translating, for example, stuff in French, but not. We are happy users of CakePHP. So thanks a lot for all the core CakePHP developers. You've been instrumental to our success as well. So I'm not going to spend too much time telling you about Passbolt because it's not an advertisement. But basically, Passbolt is an open source password manager. Everything is open source. You can share your secret with your team. It's available on iOS and Android, and in a terminal near you. So if you have curl and GPG, you can pretty much interact with Passbolt, which I think is a pretty neat feature. You don't need to install a lot of things to integrate and feed your secret into your CI/CD pipeline. So Passbolt is a password manager, but can also be used as a secret manager. So today I'm going to talk a little bit about authentication. So authentication is l'Arlésienne, as we call it in French, is this topic that always comes back and never gets solved. And if you're a developer, especially a PHP developer, you will be doing a lot of, creating an authentication layer for your application every time you start a new project. And CakePHP has been pretty good at helping people using the authentication plugin to get started and make sure that you have like proper authentication in place. But it's always a step that you need to go through every time you set up a new project. So today I wanted to share some lessons learned and some experiences that we collected along the years, because obviously we are getting old. So what is authentication? Authentication is asserting the user's identity using something that they know. So typically a passphrase, a password, a PIN. Something that they have, so typically a token, a certificate, a key, a device, something that they are, so the biometrics, so for example, their fingerprint or their face, and in some cases also something they do. So you may have seen, like for example, in crowd control, they would like use video to detect how people walk and identify people based on their gait, but there is also some banks that are using, for example, gestures. So if they know you always hold that thumb that way and you tend to swipe like this, then they will know if you start swiping differently that your account has been hacked. It's not a technology that is generally available, but like it is used sometimes. So we're not going to cover that too much today, but I just want to say that it's there. And generally, when people do authentication these days, they will use 2 or more factors. So something that you know, for example, your password, your PIN, and something that you have, like your device, or sometimes a combination of 3. So for example, the biometric will unlock your PIN or password, or like basically any combination of the 3. So we'll start with the most basic one, which is like password-based authentication, which pretty much these days, is getting challenged a lot, but still that is something that is done a lot. So I'm not going to explain too much like the process, because most likely you have implemented such a system. As Jorge mentioned in the first workshop, when you are building such a system, you should make sure that you have cross-site request forgery protection in place that is provided by CakePHP by default when you do forms. So this is to make sure that an attacker cannot, on another domain, craft a form and have a user make an action on that separate domain and basically trigger an action like deleting your account or like purchasing something on another server. So this token is quite important. And after that, when you submit the form, basically you send it back, the server will check if the cross-site request forgery token that is sent is the same as the one that is set in the cookie. And after that, you'll have all sorts of validation, like calculating the hash, comparing the hash, and starting the session itself. So obviously, there are a bunch of problems with password-based authentication. One of the most common one is phishing. So somebody can craft a fake website and have you enter your password there, and then use that captured password to log in your state. So there is also other type of attacks where for example, if your email or your passwords have been part of a leak and you're reusing credentials on multiple websites, then an attacker can try to stop that credential in other websites and see if they can log in. They can also try to brute force, so even without using leaked credentials, they can just try random stuff until it works. And if your password has been part of a leak, so for example, if there is a SQL injection vector available in your app and they are able to extract the hashes of the password, then they might be able to crack them offline if you're using like a weak hashing mechanism. And there is obviously the option for adversary in the middle. So if you're not using HTTPS, an attacker that is on the same network than you can see your password. You have something that is a bit less known, which is like password logging. So for example, if you're working for a large organization and your server is actually not the end server serving the request, but your request is jumping through a lot of hoops, these other services might log your request and might log your password in clear. So sometimes, like when you're dealing with large organization and you don't really know how the request is routed, people will implement like hashing client side to make sure that this clear text password don't end up in the logs. One last item that is also not well thought of most of the time is user enumeration. So for example, if you know my email address, or if you want to know that if I'm present or not on a given website or service, then you can try to basically submit my email in the login form or the account recovery form and see based on the behavior if I'm there or not in the system, and then use this information to craft a phishing campaign against me, because I'm using the service, so you can try to use that information to have a more elaborate attack. So implementation considerations that people work on, generally, they would try to check against breaches, make sure that the credential strength is good enough when people are setting their account. For phishing, there is obviously user training that is required, and it's one of the weakest points at the moment, because people obviously fall for that, as Mark mentioned in his workshop. And the account recovery needs to be implemented to cater for people losing their password or not remembering their password. If you have people attempting to brute force or do credential stuffing, you will need to, maybe set a CAPTCHA in place, or set up a web application firewall, or set up some alerts. You need to make sure that your hashing mechanism is set up correctly. Like, for example, CakePHP now use the default password functionalities of PHP, and it uses PayCrypt, and it's safe by default. The salt is included as part of the baseline, so you don't need to set up and manage the salt anymore, which is kind of neat. And HTTPS, even though you set it up, it can still be misconfigured, or you can be using weak algorithm. We talked a little bit about client-side hashing, which is like an edge case, but depending on where your service is sitting, you may want to consider this. And for the user enumeration, you would need to provide an experience where you have if the account is there or it's not there, you will provide the same error messages or success messages. But even there, you can still, using statistical analysis, see, depending on how you're coding, if, for example, when the user is not there, it's faster than when the user is there. You could potentially deduct if a user is there or not. And it's quite a complicated topic. And it's quite hard to implement. So one of the things I wanted to share today is this library called ZXCVBN. I've seen a lot of projects, CakePHP projects, or just plain PHP projects where people implement their own validation rules for passwords, and setting things like, oh, it should be a string with that many characters. And there's a good chance that you will be missing some obvious stuff. Like, for example, people can reuse their own email address, and it matches the parameters of using one special character and the number and a certain length. They are using something that is very weird. So this library ZXCVBN helps you implement a strong password validation and give you a score. So the advantage of this is it's available server side, it's available client side. It contains also the list of the most known passwords, and you can give it contextual data, such as the name of the person or the email, and it will make sure that the user is not trying to put the name of the service and the current year, that kind of thing. So I find, you can implement pretty easily strong password validation using this library. One of the other authentication mechanisms that you will implement when you're a developer is the account recovery link option. So the way it works is pretty straightforward. Again, we post the username and the cross-site request forgery token, and in exchange of that, the server will trigger an email notification with a token that have been generated, and the user will need to switch context and go to their email client, and then click on the link or type in the code that was sent over this link, over this email. And then the user will complete the account recovery, and you will either perform one action like resetting the password, or you will start a full session. You have a website like Medium, for example, that don't allow people to set up a password, and they just use this mechanism to log in. And so this way people cannot set up weak password. They need to use their email. So there are still some issues. So in terms of phishing, obviously you're moving the problem back to the email provider. You're saying, I don't want to deal with phishing, so you deal with it. Same with password. And so you're relying on the email provider being set up correctly. It's still possible to do user enumeration, as we mentioned, man in the middle. Similarly, if you're sending email over non-encrypted channels, so maybe there's an option there to listen to this. You need to make sure that these things cannot be reused, so your application logic needs to take care for preventing replay attack. And you have no way of knowing if that email is going to be logged somewhere or intercepted, because it's that's how the protocol works. So there is also additional issues like UX issues and potentially email delays or emails being in spam, and so the user experience is not that great. Implementation consideration: if you're doing the magic linking, you still need to train your user not to put their credential in the wrong places. You still need to make sure that user enumeration is not possible. HTTPS is required. SMTP is done over TLS. Check what is on the user side, how are they receiving their emails, if it's possible. And one of the weird things we have seen also is, depending on how you build your service, some email client will click instead of the user, and so it will count as the magic link being used, and you cannot use it twice because the client is previewing the web page and clicking in the place of the user. So sometimes people will be like, I cannot log in your service with your magic link, It's just because of the way their email clients configured. It can be quite annoying. So some of the lesson learned we had with Magic Link tokens. Ultimately, we have started reusing this authentication token in many places. So sometimes you will have like a reset password token or email validation to set up your account on a new device, and so we ended up reusing like a same table with like a token, which is like a large random token, and an expiry date that is already set directly. So one of the, instead of saying like expired, for example, Boolean true or false, we will just put the date at which the token is supposed to expire, if it's a token that expires. And you don't have to calculate the expiration date. You can just like make sure that it's set and it will be used by default. Similarly, when you consume the token, you can mark it as expire now because you've used it. So it can be like something that you want to do depending on your use cases. So using multiple types and adding some context also might be useful. So we do that, for example, in some token to verify the context. So for example, when you're doing a single sign-on, it should be normal that the user agent is the same, that their IP address is the same. If they change browsers in the middle of a single sign-on, you know that something is fishy. You can also use that to drive, for example, you know that this token is valid for a single sign-on using Azure for that particular configuration. So if for example, the configuration have changed, then you don't allow them to continue using that token to complete the authentication with the previous setting. So we use that basically free-form denormalized field to store additional information about the context, the previous action, the next action, the setting that is associated with the token when it was created. That sort of things. And one thing you may want to consider is how you're going to handle purging. So that's why I would recommend using like very strong tokens. So the largest your token, the very unlikely you're going to have collision. So this way you can safely purge them. The SMS authentication is like a variation on the theme of the Magic Link. And instead of sending to an email service, you're sending to an SMS service. So yeah, it's pretty much the same thing, except it's going by SMS. It's still possible to phish. You can still have adversary in the middle. For example, if your network is not safe, you can brute force. So for example, SMS, typically you will send like 4 digits. So there's not a lot of options. Depending on where you are in the world, and I know, for example, in the US, it's possible to have like SIM card swap. So an attacker using the account recovery option in your phone provider to take over your phone number and then receive the SMS instead of you. And this is pretty weak spot of SMS authentication, even though it's one of the most used MFA, because people assume that, service provider assume that you have a phone, so they are sure that you will know to use your phone, and so that's a pretty safe bet that you will be able to perform multi-factor authentication with your phone. But in terms of security, it's not that great. So yeah. There's not much you can do there to improve this type of MFA. Then we have TOTP. So I'm not gonna go through tips to implement SMS notification. It's not something that we do. It's not something I would recommend doing unless you're dealing with a large user base that is like fairly non-technical. The TOTP authentication is another scheme that is often used in more like services that are geared toward like a bit more technical people, where you will need to scan a QR code and it will generate a temporary code that is rotating every minute. So it works pretty much the same. You will go to your other clients and you will get the TOTP token and you will enter it in the form, and then you will check server side if that TOTP that is sent by the client is matching the configuration that you have server side. So if you have never done TOTP authentication before, it's actually fairly easy to implement. There are still some considerations that you need to take into account, like an adversary in the middle. It's still possible to create a phishing site. Still possible, if you send your site is not protecting by HTTPS to snoop on that, and it's possible to brute force TOTP. Typically, it's a 4 or 6 digit that you need to enter. So it's not a lot of options. So you need to cater for that. And there is also issues with some clients. So for example, with Google Authenticator, your TOTP tokens are synchronized without end-to-end encryption. So if somebody have access to your Google account, for example, is successful in phishing you for your Google credentials, then they will have access to your the TOTP for your other services. And that's not depending on TOTP itself, it's depending on the client implementation. And obviously, there's on top of that, now you have the UX issue of losing your TOTP. This is why Google Authenticator have implemented this sync, even though it's less safe, is to cater for this user experience issue of people losing their device that store their TOTP. So yeah, they choose usability over security there. I know that they are planning to roll out end-to-end encryption for that, but it's been more than 6 months now. So implementation consideration, user training. It's hard to teach non-technical user to use TOTP. HTTPS is required, of course, and you need to cater for the max fail attempt scenario. So you probably need to do some throttling, some alerting, and this is not really nice because, for example, if you throttle an attacker, you may throttle the regular user as well. So it's quite complicated to build this kind of systems. And for the synchronization of this TOTP, then you need to also review what kind of TOTP application your users are using, and sometimes it's not always possible. Yeah, and how to go around people losing their TOTP, you will need to have another process, typically another MFA method like SMS, or basically making it as good as the least good MFA factor, which is also not great. Otherwise, you can let people fill in the form and perform some other offline authentication. For example, if you're in a company, you can check the identity of the people yourself and disable their MFA temporarily. But if you're in the consumer world, then obviously you cannot implement that. If you have never implemented TOTP, I recommend you to check out Spunky Lab, OT-PHP library. And it's quite straightforward. As you can see here, you just need to generate 32 random bytes. This is basically 160 bits of characters. And you feed that secret into the TOTP factory create method, and then you set using the identity interface. You basically provide the username or the issuer, for example, the name of your service, and then you get, in exchange of that, you get provisioning URI. That provisioning URI can be used to generate the QR code that is used for scanning the secret and storing it on the phone. Here, for example, is an example on how you could render the QR code as part of a CakePHP view cell. And you have some options in terms of image rendering. Like here, we are rendering an SVG, but you can also do that with a PNG if you want. There are many options. You can also choose the size you want and the density of the QR code, that sort of things. So we have here an example of how to validate a TOTP using a form in CakePHP. And as you can see, it's pretty straightforward. You load the TOTP provisioning URI into the factory, and you provide the value, and you verify, and you get a Boolean injection. So it's not so hard to implement. What is hard to implement is the user experience around people losing their TOTP. So another method of authentication that is used quite a bit is Road to OTC. So for example, if you're using Azure or Google SSO, this is typically a protocol that you will need to implement. There are several flows. Here I'm showing like code flow, which is, I would say, like one of the most popular that you will see. You have other type of flow like hybrid flow, or even like with Azure, you have like a flow that they call OpenID Connect, which have like less back and forth. But they are pretty much around the same, based around the same kind of concept. So here you will, the client will start their single signing process, and the resource server, which is your application, will create a URL for which the user will be redirected to. That URL includes the client ID, the response type, which is like the code flow. It contains again also a state and a nonce and a scope. So the state is used to make sure that cross-site request forgery attack are not possible, and the nonce, the scope is used for OpenID to specify that this code will be used to give you some information about the user, their email, that sort of things. So typically, if you have other capabilities, like you don't necessarily just want to have their user identity with that code, but you want to perform some additional information, some other requests. Some service like Azure, for example, will allow you to read their emails or do all sorts of things, like read their emails in their mailbox and not just get their email address. So then, based on that, the client is going to the authorization server. So it can be like a Google, or it can be any OAuth2 compliant server like Azure or GitHub or whatever. And the user is redirected here again with the code. So the code is what you will use from the resource server to query the authorization server to get some information about the user. And the state is also returned and is checked against what is there in the URL and in the cookie. So this way you have the cross-site request forgery protection, like we've seen with the cross-site request forgery token in the previous flows. And next, the resource server is using that code to get some additional information about the user. So typically, if it's compatible with OpenID Connect, it will give you like a GWT, which contain information about the user, such as their email and other claims that you've requested in the scope, and as well as a nonce. So the nonce will be used to make sure that the initial request that you did is correlated with the final request. So this is to prevent scenarios, replay attack scenarios coming from an attacker that would pretend to be an authorization server. And yeah, that's it. After that, you need to validate the GWT. You check the signature, you check for the expiry, you check the issuer, which is like the domain, to make sure that the domain is matching the authorization server, and then you can actually log in. So there are still some security issues with Road2 OpenID Connect. One of them is cross-site request forgery, which we have seen. Like, you need to make sure that the state is set and checked correctly. Same for replay attack. You need to make sure that you check the nonce and you check the GWT expiry. It can still be adversary in the middle, and so you need to check that you have HTTPS and GWT signature as well. One of the key problems is if the service is unavailable, then people cannot log in and will need to basically fall back on using their email, which is not great. So for services like Google or Azure, it's quite rare when they go down, but they do sometimes, and so that might also like affect your service as well. Yeah, there is some problems also depending on how OpenID is implemented. For example, in Azure, the emails are not necessarily verified. It's the same for Google. They will tell you if an email is verified or not. So you cannot always trust the information that is in the GWT, and you will need to actually read the specs of your auth provider to make sure that like the claim is actually what you expect. And maybe an email means is not. It's a free form field that anyone can fill up in their interface, and you cannot use that for authentication. There are some concerns around privacy. So every time you log in into a website, Google or Azure will know about it. So maybe it's a good thing if you're like in a enterprise environment, because then you can use these logs to set up alerts and integration with your security systems. Like I know, like Cedric never works on Sundays. Then I know if he logs in the middle of the weekend. No, he's saying he works on Sunday sometime. Okay, so we'll disable that alert. But you can do this kind of things. It's still obviously possible to set up phishing to steal the credentials that are used on the single sign-on provider side. I'm not going to go in how you can implement OAuth 2 because it's as you can see, there's a lot of checks and a lot of like steps. But I would just give some feedback. We've been using like League OAuth 2 client, which is from PHP League, and it's quite nice. But it doesn't do like GWT signature verification. So it doesn't do the OEDC part. You need to implement this yourself. So just be careful if you go there. If you want some extra safety about like the GWT signature, you need to check, do some discovery around like getting the certificate from the service provider. So this, you will need to build that yourself. There are some other considerations like Azure secrets that are used in the last step. For example, you send the client secret to connect to the authorization server, and you need to store that secret on the resource server, and it expires after some time. So if you forget to rotate that, then your SSO might be broken. And so if this is something to remember, to make sure that you notify your administrators that their SSO integration needs to be refreshed every once in a while. One of the things that we've implemented in Passbolt is, for example, we make sure that the admin complete the flow themselves before enabling SSO. So this is to prevent like the admin saving a wrong SSO setting and basically like rolling out the SSO to their user even though it's broken. So you would want to like make them play that flow and use the fact that they completed that flow to save the settings. So this is one of the use of the token, the authentication token that I mentioned at the beginning. So we use, for example, this context information. This is an administrator that is doing a trial MFA, trial SSO for these particular settings, and in exchange of that, they will get a token, another token that will allow them to save these settings. So we have this mechanism built in to make sure that people don't shoot themselves in the foot. So one of the last topic I wanted to cover is the future of authentication. Mark did a workshop on that on the first day, and it's an interesting an emerging topic. So you've heard, for example, about FIDO, passkeys, WebAuthn, U2F, CTAP, and so I'm going to give a primer again in case you missed Mark workshop. The FIDO2 project is a project that is a joint effort between FIDO Alliance and the W3C. This project aims to kill passwords. So basically make sure that people do not fall for phishing anymore. So it's composed of several components. One of them is the WebAuthn. So WebAuthn protocol is the part of the protocol that connects the client, your browser, and the relying party, so a website, a PHP application, if you will. But it has also another component, which is called CTAP, which is the protocol between the client and the authenticator. So, for example, if you are using like a YubiKey, the protocol to connect to the browser from the USB key will be different than, for example, if you're using your phone. And we will see what are the different options, what are the different type of authenticators that are there. So there are hardware-based authenticators that can work with a USB or NFC, but you also have some other authenticators that are based on Bluetooth, for example. So this whole thing, these two protocols and this relationship between the authenticator, the client, and the relying party is what is included in the FIDO2 project. So the WebAuthn part of the specs is mostly sitting with the W3C, but people from the FIDO Alliance are obviously sitting there and talking about it. And you have like CTAP. The specifications are available on the FIDO Alliance website, and obviously the two are very strongly related. So how does it work? Like a passkey, there are different definitions of passkeys. So it's a new term that was coined like 2 years ago, because like obviously CTAP and WebAuthn is not a very sexy name if you want like mass user adoption. So what is a passkey? It's a private public key pair that can be used to authenticate. And one of the new things that was added recently is the ability for these passkeys to be shared across multiple devices, as opposed as making these keys hardware bound. So it's still possible to use keys that are hardware bound, but it's also possible to use keys that can be synced across devices. So for example, if you're in the iOS ecosystem, you can have like a passkey on your phone, and that passkey on your phone through the iCloud keychain will be basically made a copy on your laptop. So in a nutshell, the way it works is the client data that is sent by the relying party and the client, the browser, is hashed and signed using a key that is easier hardware bound or that can move around. And additional to that signature, some data related to the authenticator. So for example, if I'm using YubiKey, I will have like maybe like some information about the certificate that is used to generate these keys, and information about the properties of that authenticator. So that if, for example, if you're in the FIPS environment, you're like working for the government and they recommend using only certain algorithm or certain configuration of the algorithm, like some information will be there about the authenticator. It's not always there, but the client can request this data to be there. And then to verify that signature, then we take that signature, we take the public key that was registered during the initial setup, and we verify that the signature is valid, and we compare the client data with the original client data. So for example, the RPID, that sort of things. So in practice, this is how it looks, the flow. So your client will use HTTP protocol to request for assertion options. So this is the login flow. I'm not going to do the registration flow, but they are like very much the same. There's a little twist in the registration, but like the login flow will give you enough information about how this works. The login flow is called the assertion flow. It's just the way it's called. So the client sent the username and request basically the relying party to give him information about which credentials are registered and can be used to log in. So at that stage, you will have the relying party will give you a challenge, something to sign, something that is truly random that you need to sign, the ID that is used by the relying party to identify itself, the list of passkeys that are registered on their website, and some options like the relying party wants the user identity to be verified strongly or not. So sometimes you want relying party are optimizing for speed. So for example, you're part of a checkout workflow. You don't want the user to do like very strong authentication. You want them to pay fast and then solve the problem later. But in some other context, you want to go slow. So you want them to have like a strong biometric check. And so the relying party can basically give some options based on that. Obviously, the client can take these options as a suggestion of presentation, or like ignore them and then let the relying party decide if the authentication that was made was as per their request. Then the client switched to the CTAP protocol. So in the JavaScript environment, you will call a method called navigator.credentials.get. So you have in the navigator, the credential API is the one that does the interface with CTAP. So there is not like a, so it's reusing another set of APIs to do that. So it's not a dedicated protocol. You can use navigator credentials to do other things like, that is not related to WebAuthn, but basically this WebAuthn and the credential API are working together to trigger the start of the CTAP protocol. And then the client will trigger a function in CTAP that is called authenticator get assertion with the RPID and the hash of the client data. So the identity of the user at that stage is not provided to the authenticator. So this is like a privacy functionality that is built in the protocol to make sure that that the personal identifiable information are not roaming around if they are not needed. And then you will have some the authenticator will perform some checks, but for example, checking if the RPID is matching the ones that is there for that key, that sort of things. And then the authenticator will provide authentication data, the signature, and information about the context. And then the client will send this assertion response back to the server with the client data JSON, the authenticator data, the signature, and the user handle. And then the relying party will verify the signature, assert the RPID, so make sure that this signature is actually the signature for this site and not another site, and proceed with logging the user. So you've seen talk about like this flow completely replacing the login flow or being used on top of the login flow as multi-factor authentication. So it depends, for example, on the options that you're providing at the beginning. So some sites, for example, Google, will consider that if you use your phone, then it means it's something that you have. And because to unlock your phone, you need to have biometry or know your PIN, you already have two-factor authentication. So you can use this to log in. But like, for example, if you're using a YubiKey, as Mark showed initially, that don't necessarily have a PIN, if for this exchange, the PIN was not requested, then you don't have several factor authentication. You just have like something that you have, which is the YubiKey, and something that you have, which is something on the YubiKey. So it doesn't count as a multi-factor. But yeah, it depends on your requirements and how many factors do you want. So how does it look? So these things are under heavy construction. There's a lot of work happening at the moment on like what the user experience should look like. And so I'm just going to give you if you've never tried setting up passkeys, basically I'm going to do that for you so you can see like how it feels. So here is on macOS and Chrome. So when you go and do the registration process, a pop-up that is managed by the browser will come on top of the site, and then it will propose you to create a passkey. So there is already like a preference here. Chrome is basically saying, we're going to store these passkeys in the password manager of Google. And I'm going to use Google to synchronize this passkey around. So here you can see that this is already problematic because Google is making a choice for you on like how you want to sync these things. And for most users, it feels like just like macOS asking for their fingerprint, but they don't really understand where the things are going to be stored. And we'll see why it's important later. So there is another option for Flow. For example, if you want to use a hardware key, then you can select and click on Use Different Device, and then click USB key, and then click insert your USB key, and then press it, and then click Allow. So you can see already that they are making sure that this experience is not as good as the one that they proposed by default. So and this is the experience on Chrome. If you've seen Mark workshop, he was using Firefox, and there was no proposal for anything else than a YubiKey, because like currently Firefox only supports YubiKey. So you can already see, for example, somebody that used both Firefox and Chrome, their experience would be like, okay, what's happening? Why is this one proposing me this? Why is this one not proposing me the other one? So yeah, this makes the user experience very fragmented. How to manage your passkeys when you're using macOS and Chrome? First, you will need to go to Settings, and then you need to click on Manage Passkeys, and then you will go back to Settings with Autofill and Passwords, and then you have the list of your passkeys. If you click back on passkeys, then you cannot go back. You have to do the whole thing again. It's crazy. Like they really hide that Manage Passkey screen like very far. And the issue with this is that if an attacker managed to set up additional passkeys, for example, they managed to abuse the account recovery flow to create and register a new passkey for you, then like you will not be able to see it. It's the same like here. On your computer, you will not know like which one are installed unless you know already where to go. So for example, you will not know, is this passkey managed by Chrome? Is it managed by someone else? Is it managed on my phone? Like, I don't know. And you have to jump through a lot of hoops to understand like how many passkeys do I have and where are they located. If you're using macOS, Chrome, and iOS, so as I mentioned, you can do you can do that. So you have a you click on Use a phone and tablet, and then you will have a QR code, and then you will take a picture, and then at that stage, the Bluetooth protocol will be used. So it's using Bluetooth low energy, which have a range, estimated range of 50 meters, which is quite a bit. And you don't need pairing for using that protocol. So that's why they've used it. Generally, when you, for example, you install your, like I don't know, like a soundbar, or like you link two devices together, your car and your phone, like you will have like a sound pin that you need to enter. With BLE, you don't need that. So that's why they choose that Bluetooth protocol for exchanging data offline. So yeah, then you will be prompted to sign in, and you will have like a biometric check on your phone, and you'll be able to log in. Similarly, how do you manage your passkeys on iOS? Well, you need to go to not to passkeys section, in the password section, and then you need to basically find click on an entry to know if it's a passkey or if it's a password. So again, like it's not very convenient to understand whether this thing is a password or passkey, especially for non-technical users. On Safari, completely different experience. Obviously, Safari is a macOS product, so they're going to push you to store information into the macOS keyring, but it looks a bit the same than Chrome. So if you're using both Safari and Chrome, you're like, okay, I thought I was storing it in my browser, but here now I'm storing them in the keychain. So again, it's a bit confusing. And then if you go for other options, then you can pretty much do the same with security key. Here you can see like the first time I tried to set it up, I got like an error. I don't know why. It was on the YubiKey test site. So they might have some issues there. And then the second time I came back, I had like an option to set up a pin for my security key. And something you need to know is that on the YubiKey, you can only store 25 passkeys with a pin. So that's also a limitation that is not necessarily well known. And if passkeys are being rolled out like everywhere, if every time you use your security key, YubiKey, and it requires a pin, then basically you can only have 25 sites that does this before, So, and I don't know what's the behavior when you reach that number. It's like, is it like forget the first one, or it's showing you an error? I don't know. I've not tried it. I don't want to break my YubiKey. So managing your passwords on macOS is the same. We've seen here in the message, a passkey would be saved in the iCloud keychain. So I go to iCloud in my keychain, it's not there. No, what you need to go to passwords, and then like you can see your key finally. And similarly to iOS, you don't know if it's a password or if it's a passkey. So obviously passkeys are only as strong as the account recovery mechanism. So I dig a little bit on like what is the account recovery mechanism for iCloud. I didn't have the time to do it for Google, but I suspect it's pretty much the same thing for Microsoft. I've not checked, but for Google, I know that they require you to have another device enabled, and for iCloud it's the same. So you must authenticate using your password, and then SMS would be sent. So basically, there would be like some form of handshakes where you have like your device. When you're adding a new device, there would be like a key exchange using iCloud, and you would be able to liberate that key from one device to the other. But it will only be allowed to move between, secure enclave of your phone to another secure enclave of your phone. You will not be able to read that key. It will be transmitted in a format that only the secure enclave can understand. So if you want, there is a link. You can read more about that. I must say, like it's quite well documented compared to some other providers. So you have solved a lot of problems with you have removed phishing. You have removed the need for man in the middle. You cannot do credential stuffing. Like you need to. Every authentication attempt is unique. Every time it's using like a random challenge. So an adversary cannot like try a random challenge. They cannot be brute forced. If you have like even a leak of the public key, it's completely useless. And you cannot do adversary in the middle because HTTPS is required to be able to use that WebAuthn protocol. It's the same. You don't have password login anymore, but you still do have the user enumeration problem. So if we go back to the first step, we see that here on the assertion options, we send the username, and this is quite problematic because if you're an attacker, you would know, okay, this person is registered on that site, and then you can basically craft some attacks around that information. And you still need account recovery, and we see like the account recovery, because it requires end-to-end encryption. It's not like a trivial thing, and so if you lose all your devices, basically you're gone. That's it. You cannot recover. So it's also like a good marketing thing, because like you will need multiple devices. So there's more devices to be sold, and you still need a lot of user training. In my opinion, this thing is not ready for prime time when it comes to like mass adoption beyond like using it as a second factor authentication. You will need to read the small prints also of the services, like, so it's not an exercise that people will do, I expect. So you solve all this problem, but you now have a new category of problems. So like one of them, like we solve phishing, but we introduce all these other problems. So we touch on passkey lost. We've touched on physical proximity. Like if an attacker is within range, they could potentially use that. It's not trivial, so I'm not considering this as a big issue. But if you're like, I don't know, like a journalist or like a whistleblower, this might be interesting information for you. Then you have passkey management and review. So for example, if an attacker, if your service, if the relying party is not showing you clearly what are the passkeys that can be used to log in on this site, an attacker can potentially, manage at some point to add a passkey, and they will have like a nice regular login. And so you need to train your users to manage their passkeys. And we've seen in the interface that this is not very easy to do at that stage. And I've not even touched, I've just touched the client side, but I've not even touched on the RP side to explain like the passkeys. Are the passkeys available to admins? If the keys are roaming around, and we've seen, for example, with Passbolt, if you use Microsoft Hello, you expect that everything is private to an application. It's not, depending on how your laptop is configured, depending on what kind of application you have. This information that are available via Microsoft Hello might be available to other applications. And it's not trivial. You need to do a lot of research to understand who can access what. There's the user enumeration and the privacy problem. So we've seen that, for example, if passkeys are not, if an authenticator is not playing by the book, or if a client is not playing by the book, they could have information about the client. So there is a lot of privacy consideration for clients and authenticators, where you as RP also, you also have some information to protect. For example, one of the things that we will talk about is making sure that you don't use the email as the login, but you use like a completely random ID. So this way, like you protect your user with some additional privacy. There is also the option that, for example, the root CA or some intermediate certificate is leaked at some point. So we've seen this with public key infrastructure in the past, for example, with SSL. You do have some root CA that are compromised at some point, and people can forge certificate for google.com. So this can be quite problematic. And this basically the same problem would also be available for passkeys. So for example, if the YubiKey root CA leak, then an attacker will be able to pretend to forge any signature. And so this can be quite an issue. It will be like a rare event, but you will need to be ready to deal with it when it happens. Similarly, you have some issues around quantum computer. So it's related to this. Public key infrastructure is not quantum resistant at the moment. So when quantum computers will be available, if they are, then that might become a problem. So the fact that quantum computers may or may not be there in the future, and the fact that root CA may leak or not, you will need to build in some crypto agility. So like right now, like there is very limited set of algorithms that are used for signatures, and they are not post-crypto resistant. And so if we start adding post-quantum cryptography, we will need to support the old algorithm and the new algorithm, and we'll probably need to roll them out at the same time. And you will also need to implement crypto algorithms that are quantum resistant and have different variations, because maybe one may become compromised. So this is like for people that have been in the software industry for a long time, they will remember that the crypto systems were not as stable as they are now in the past. And so you would have like a RSA cyber, like some issues around RSA or some optimization or some problem around RSA, but like for the last 10 years or more, like this algorithm have been like quite optimized and quite stable. And we're gonna move to an area where these algorithms are not necessarily safe, and we will need to be agile and be able to switch them. We will be able, and so for you, if you implement passkey as your main authentication system, you will need to pay a lot of attention on how I'm gonna rotate keys. So for example, I know this key was using this algorithm that has been compromised. So now I need to rotate all my users' keys. And how do you do this? In which order? Like, how do you notify your users to do this? And these are not trivial problems to solve, in my opinion. But the more you start thinking about them now, in your design, you will be a little bit ahead of the curve with these problems. So yeah, that's pretty much the security issues. There are some other issues around passkeys. I think, with passkeys, we are kind of in the hype phase, so everyone is like super hyped up about it because, it prevents phishing, and I think it's great. But like at some point, people will start to, like see the downside. And I think like the faster we reach that point where like people are like have digested and like their hype and went down through that phase where they hate passkeys, then we will probably like have the opportunity to have like really good passkey implementation and adoption. So the end user experience is going to be key. In FIDO, there's the UX working group that is working hard on this to make sure that there is a unification between like what service providers are requesting in terms of options, and also like the way authenticator and client are behaving. Because right now it's the wild west. And there's obviously like specs. The specs are moving a lot, and the specs are being pulled in very different directions. So you have on one side, website like I don't know, like Amazon that want very fast checkout, seamless user experience, and on the other side you have like banks that want like to know like exactly what kind of version of the YubiKey you had, what kind of algorithm that you use. So these are very different requirements, and they are all built in the same protocol, and so that makes it like quite hard for developers to understand. Okay, I have all these options. What should I choose for myself? Then you have also like some gatekeeping around authenticators. So, for example, if the bank starts saying like, okay, I don't like these devices, or like I don't like, for example, iOS, then you might even have like a more fragmented ecosystem. So, similarly, if the barrier at entry for you to build an authenticator is too high, then you will not have like open source alternative. You will not have. You need to use proprietary authenticator, and like authentication is the business, so there is like a vested interest behind it. So that might be an issue on the long term. For example, password managers are not considered good enough to be authenticators at the moment, even though we are part of the FIDO Alliance with some other password managers. There is, we are considered like the least safe option to store stuff because we don't have hardware capabilities like the secure enclave, which is obviously better than just encryption with keys that can be exported. But still, the password manager have the habit, the experience on like building user experience for people to log in safely. And so right now, for example, credential manager like Dashlane will completely bypass the WebAuthn authentication implementation in the browser and inject in JavaScript their own implementation of the WebAuthn endpoints, and basically be able to hijack this JavaScript environment, replace the primitives to trigger their own version of CTAP. And it's called monkey patching, which is basically you're overriding the JavaScript primitive of the engine, of the browser. And but this is the only way for credential managers to be able to act as authenticator, at least in the browser. So there are discussions with Apple and others. Like, people have very different opinion about the subject. Like, Apple is more trying to go down the route of like forcing credential manager to have a desktop app to be able to talk to the account keychain. Microsoft doesn't really want to integrate, as far as I know. And you have stuff like, for example, Ubuntu or Firefox. The support is almost inexistent. So then it makes things quite complicated. For the open source community is not really going to have the same chance to play than the big players that have hardware access, or that have marketplaces or a browser. FIDO Alliance is a paid pay-to-play initiative. So like there is no, basically you'll find banks and the GAFAM, but there are no like actor of the civil society at the moment. So like when it comes to making specifications that are like super important for if it's supposed to replace password and like be used by everybody to authenticate, is it a good thing that like only the big corporations are involved and not the civil society that might have, for example, the journalist or the whistleblower might have different requirements than these banks. So this is something to think about, and if you are interested, then I invite you to get involved. And like as Mark mentioned, like I'm not an expert as well. Like I'm not an expert of that topic. I think it's an important topic to get interested in. And if I say something wrong in this presentation, and for sure it's false, then please do and come ahead and tell me. And if you have questions and all, then I'm happy to discuss that further with you. That's it for me. I'm not sure if we have time for questions, but
less than 5 minutes.
Yeah.